Hi, welcome back. Let's take a look at this Doppler effect question. Question number 6 reads, a learner in a car moving at a constant speed of 10 meters per second along a straight horizontal road records the frequency of sound emitted by a distant stationary source. Okay, so from that we can get that the listener is moving. So VL is 10 meters per second and Vs is equal to 0. The learner then repeats the recording of the sound when the car travels at a new speed, 20 meters per second. Okay, so VL is then 20 meters per second. And then Vs is 0. The graph below, not drawn to scale, is obtained from the results. Okay, we have a recorded frequency against speed of car. Now the question reads, write down the frequency of the sound emitted by the stationary source. Okay, give you a reason for the answer. Now, because the listener is moving, there's going to be an apparent change in the frequency. So the frequency that's being heard is not the true frequency. So you will get the true frequency when both the listener and the source are stationary. Now we know that the source is stationary, but the listener isn't. The car isn't. So what we can do is we can extrapolate our graph backward like this to where the speed of the car is 0. And that tells us that that y-intercept, that 700 hertz, is the frequency of the source. So the frequency of the source is equal to 700 hertz, and that's because the listener and the source are stationary. Okay, let's write it down here. 6.2.1, frequency of the source is 700 hertz. Why? Because both the listener and the source are stationary. Okay. Let's move on. Question 6.2.2. In which direction is the car moving relative to the source? Is it moving away or toward? Okay, so, and give a reason for your answer. So 6.2.2, we can see that the perceived frequency, or the frequency that's heard by the listener, gets smaller. And the only time that the frequency of the listener is going to get smaller is if the listener is moving away. So the answer is away. And why is it away? Because the frequency of the listener is less than the frequency of the source. If they were moving toward each other, then the frequency would be higher. 6.2.3, calculate the speed of sound in air. Okay, so we have enough information. Let's just make a note of it. We know VL equals 10 meters per second. We know VL in the second experiment is equal to 20 meters per second. And in both cases, we know Vs is 0, Vs is 0. And we know that it's moving away. So we'll start with our Doppler effect formula. So the formula is FL is equal to V plus minus VL divided by V plus minus Vs multiplied by Fs. Now, since it's moving away, we're going to have a small top and a big bottom, meaning a minus on the top and a plus at the bottom. So our formula is going to be, now we can substitute any value. So let's use this pair. So this one here and this one here. So the frequency of the source, so the frequency of the listener rather is 679.1. So 679.1 is equal to V, then we're going to have minus VL was 10. Yep, correct. Divided by V plus 0. Because remember the source is 0. So this is the one that we're using. Right? And then multiplied by 700. Let's simplify. 679.1 is equal to V minus 10 divided by V multiplied by 700. You can then solve for V, and then you get V equals 333,33 meters. Sorry, it's 334. 334,93 meters per second. And that's it. If you found this useful, please leave a like, share, and subscribe for more. And if there's something specific you'd like me to do, let me know in the comments below. And until the next one, bye-bye.